Have you ever wondered what lies beyond the visible realm of our solar system? This question, intriguing yet often overlooked, deserves our attention. When we gaze up towards the night sky, our eyes meet the planets and celestial bodies that form the visible part of our solar system. But beyond what our eyes, or even our telescopes can perceive, exists a non-visible realm, shrouded in mystery and ripe for exploration. Buckle up as we venture into the unseen territories of our solar system. So, what exactly is the non-visible part of the solar system? Well, it's not as mysterious as it may sound. When we talk about the non-visible part of the solar system, we're referring to areas that are simply too far away to see with our naked eyes from Earth. These include some truly fascinating regions like the Oort cloud and the Kuiper belt, along with other distant objects. Let's start with the Oort cloud. Imagine a vast, spherical shell enveloping our entire solar system. This is the Oort cloud, named after the Dutch astronomer Jan Oort. It's believed to be a giant swarm of icy objects, remnants of the material that formed the solar system billions of years ago. Then, we have the Kuiper belt, a region of the solar system beyond Neptune's orbit. It's like an extended version of the asteroid belt, but much larger and farther away. The Kuiper belt is home to many dwarf planets, including Pluto, the most famous of them all. And then, there are countless other objects scattered throughout these regions, many of which we're still discovering. The thing is, these areas are so far from the Earth and the Sun that we can't see them without the help of powerful telescopes. But don't let their invisibility fool you. These areas, while invisible to the naked eye, hold many secrets waiting to be unveiled. Our first stop in the invisible realm is the Oort cloud. Imagine an enormous, distant spherical shell enveloping our solar system. This is the Oort cloud, named after the Dutch astronomer Jan Oort, who first proposed its existence in 1950. It's located way out there, nearly a light year away from our Sun, which is about 1,000 times the distance between the Sun and Neptune, the furthest planet in our solar system. The Oort cloud is immense, stretching from 50,000 to nearly 200,000 astronomical units from the Sun. To give you a better idea, 1 astronomical unit, or AU, is the average distance from the Earth to the Sun. So, we're talking about an area that is incredibly vast, far beyond the 8 planets that we know. Now, what's inside this colossal cloud? It's filled with billions, maybe even trillions of icy objects. These are not just ordinary ice cubes, but chunks of rock and metal coated in various types of ice, such as water, methane, and ammonia. They're leftovers, remnants from the time when our solar system was formed about 4.5 billion years ago. Perhaps the most fascinating part about the Oort cloud is its role as the birthplace of many long-period comets. These icy bodies get disturbed by the gravitational pull of nearby stars, or even by the Milky Way itself. Once dislodged, they plunge into the inner solar system, becoming what we know as comets. Familiar names like Hale-Bopp and Hyakutake, these spectacular celestial visitors, were born in the Oort cloud. While we've yet to directly observe the Oort cloud due to its vast distance and the small size of its components, its existence is widely accepted in the scientific community. It represents the outermost boundary of the Sun's sphere of influence, where the solar wind slows down and merges with the interstellar medium. The Oort cloud, while elusive, is a crucial part of our cosmic neighborhood. Next, we delve into the mysteries of the Kuiper belt. A seemingly endless expanse of icy bodies and dwarf planets, the Kuiper belt is a fascinating region of our solar system. It's located beyond the realm of the 8 planets we're familiar with, starting just outside the orbit of Neptune and extending outward into the farthest reaches of the Sun's gravitational influence. The Kuiper belt is home to a multitude of intriguing objects. Dwarf planets like Pluto and Eris are among the most well-known residents here. These celestial bodies, though smaller than our more familiar planets, have enough mass to maintain a spherical shape, making them fascinating subjects of study. But dwarf planets are not the only denizens of the Kuiper belt. This region is also teeming with countless smaller objects, often referred to as Kuiper belt objects, or KBOs. These KBOs are composed mainly of rock and ice, remnants from the early days of our solar system. Some of these icy bodies occasionally find themselves pulled into the inner solar system by the gravitational forces of the larger planets, becoming what we know as comets. The Kuiper belt is not just a collection of icy objects floating in space, though. It is a time capsule, preserving the conditions of the early solar system. By studying the Kuiper belt, scientists can gain invaluable insights into the origins of our solar system. The composition of the KBOs, the orbits they follow, and their interactions with other celestial bodies all provide clues about how our solar system formed and evolved over billions of years. The more we learn about the Kuiper Belt, the more we realize its significance. It's not just an outer boundary of our solar system, but a gateway to understanding our cosmic past. Each icy body, each dwarf planet, is a piece of the puzzle, helping us piece together the story of our solar system. The Kuiper Belt is a cosmic treasure trove, a snapshot of the early solar system. Beyond the Oort cloud and Kuiper Belt, there's still more to explore. Our solar system is a vast, complex tapestry, filled with an array of non-visible objects and areas that are as fascinating as they are mysterious. One such area is the realm of trans-Neptunian objects, or TNOs for short. These are minor planets, asteroids, and other small celestial bodies that orbit our sun at a greater average distance than Neptune. They are a diverse group, ranging from the well-known dwarf planet Pluto to the more obscure Eris and Makemake. Interstellar objects also pique our cosmic curiosity. Take Oumuamua, for instance. This elongated, cigar-shaped body is the first confirmed object from another star system to pass through ours. Its high speed and unusual trajectory offer tantalizing hints about its origins and the star system it may have come from. Then there's the heliopause, the theoretical boundary where the sun's solar wind is stopped by the interstellar medium. It's like the final frontier of our solar system, where the influence of our sun ends and interstellar space begins. Detecting and studying these non-visible objects and areas is no easy feat. It requires the use of sophisticated telescopes and other detection methods, along with a hefty dose of patience. For example, trans-Neptunian and interstellar objects are often discovered by observing their effects on other celestial bodies or their interaction with solar radiation. Scientists also use mathematical models to predict where these objects might be and to understand their composition and structure. These distant objects and regions remind us that there's always more to discover. As we continue to explore the non-visible solar system, we not only gain a better understanding of our own cosmic backyard, but also of the universe at large. Who knows what other wonders are waiting to be discovered in the vast, uncharted territories of our solar system? You might ask, why does exploring these invisible areas matter? A valid question indeed, and the answers are as vast and intriguing as the cosmos itself. Firstly, these invisible parts of our solar system offer invaluable insights into the formation and evolution of our very own celestial neighborhood. By studying these areas, we can gather clues about the early stages of our solar system, when planets were just beginning to form and the universe as we know it was taking shape. This knowledge not only helps us understand our past, but also enables us to predict future changes and developments in our solar system. But the exploration of the non-visible solar system doesn't stop at understanding our origins. It also opens up a whole new world of possibilities for discoveries. Imagine, for a moment, the countless objects and phenomena that are yet to be discovered. Comets, asteroids, dwarf planets, even entire fields of cosmic debris, all waiting to be found and studied. Each new discovery adds another piece to the puzzle of our universe, enriching our understanding of the cosmos. Now let's take a leap into the realm of the extraordinary. The non-visible solar system also holds implications for one of the most exciting and enduring questions in science: the search for extraterrestrial life. Could there be life forms, however primitive, lurking in the distant icy worlds of the Kuiper Belt or the Oort cloud? While we don't have the answer yet, the possibility alone is enough to fuel our curiosity and drive our exploration of these invisible regions. In essence, the non-visible parts of our solar system matter because they hold the promise of new knowledge, new discoveries, and potentially new life. They challenge us to push the boundaries of our understanding and to venture into the unseen, sparking our curiosity and our sense of wonder. The unseen parts of our solar system, though distant and elusive, hold keys to understanding our place in the cosmos.